So this is a new section. It's on inverse functions. So we're going to just start with graphing an inverse function. So in black, I have my x squared function. And in green, I have my x to the 1/2 function, which is the same as the square root of x. So the way that we get that is our index is 2. Our exponent is 1. So it is 1 over 2. So it is the exponent, when it's a fractional exponent, it is actually a root. So if you need to review that a little bit, you can go back to the exponent videos. So the first function we're going to graph is the function f squared. So remember, your x values are your independent variables. What it spits out is your dependent variable. So I can pick anything I want for my x values. What it spits out depends on what I put in. So if I put in 0 for my x value, I plug in 0 here. 0 squared is 0. And I'm going to plot the points as I go. When I plug in 1, 1 squared is 1. So when I plug in positive 1, it spits out positive 1. When I plug in negative 1, negative 1 squared is positive 1. So when I plug in negative 1, I get out positive 1. When I plug in 2, 2 squared is 4. So when I plug in 2, it spits out 4. And the last one, when I plug in negative 2, negative 2 squared is also 4. So when I plug in negative 2, I get out 4. So my x squared function is this parabola. You're going to pretend that it is symmetrical on both sides. Okay? So that is our x squared function. Now we're going to do our square root of x, or x to the 1/2 power. So with this one, what I want to do, since I'm looking for a square root, I'm going to just plug in perfect squares. It makes it much easier to graph. Okay, so when I plug in 0, square root of 0 is 0. So there's the g function. When I plug in 1, the square root of 1 is 1. So when I plug in 1, I also get out 1. So I'm making it a little bit bigger than the black one so you can see that the points are in the same spot. Now, this is where I want to put in perfect squares. If I plugged in 2, I could get the square root of 2, which is about 1.41. But because I want to just keep it even, I want to keep it easy to graph, I'm going to plug in perfect squares. So the square root of 4 is plus or minus 2. So when I plug in 4, I'm going to get out a positive 2 and a negative 2. When I plug in 9, I'm going to get out positive or negative 3. 5, 6, I got to keep it going. 7, 8, 9, and I'm going to get here and here. So my square root function is going to look like that. Now, the reason why I don't use the negative version is because if I use the negative version, I no longer have a function. Okay? So we are only going to graph the positive version of my square root function. Now, what you notice is these two functions are symmetrical, or they lay opposite my y equals x function. Okay? What you'll also notice is if I plug in, if I name these points, this point right here is 1, 1, so there's really no difference here. This one is 0, 0. This pen is not working. Okay, so I have 1, 1, and I have 0, 0. So that there's not a big significance on that. But when I plug in this one is 4, 2. Well, on my x squared graph, I have a point 2, 4. If I were to keep going on my x squared, I'd have a point at 3, 9, which, if you remember, this one was 9, 3. So what you're seeing is my x's and my y's flip-flop. Flip-flop. It's 2, 4 here, it's 4, 2 here. It's 3, 9 here, it's 9, 3 here. Well, what you're seeing is when you have inverse functions, the inverse function means that the x, y in one function is the yx in the other function. Okay? So our inverse function means our x's and our y's reverse or become inverse or opposites of each other. And an inverse function, you'll see that every single time. So the inverse functions that you have seen throughout your math career is the inverse of adding is subtracting. The inverse of subtraction is addition. The inverse of multiplying is dividing. And now you see the inverse of something squared is the square root. Well, what we're going to do now is, remember we have just stepped into the exponential functions. So we have the base is the number, and now the x value is our exponent. It's completely different than what we've been working with. So now what is the inverse of an exponential function? Well, the inverse of an exponential function is a logarithmic function. Rhythmic. That's a y function. Oh, sorry, I'm spelling it wrong. There we go. Okay, a logarithmic function. They're inverse operations. So we have two specific logarithmic functions that we're going to be working with. We're going to be working with the exponential function of e to the x, and the inverse of that is ln of x. And then we're going to be working with a common log, and the inverse of that, oops, I'm doing it backwards. We're going to be working with a common exponential function and a common log. Okay, now this first one is what we're going to do in the first series. So this right here was just an introduction to what inverse operations are, and now we'll get into the specifics.